Hello everybody, in this video we are going to continue our conversation on how to use the law of exponents to simplify expressions. In the previous video we did talk about a little bit of the vocabulary words. We need to know that the big number in the front is a coefficient. Any of the letters are considered variables, and if they are raised to a power it is also considered a base. And then the number that is our exponent is what's going to be raised to a particular power. So it's going to be our smaller number. We talked about how to go step by step and how to organize so we can simplify some of our problems. We also mentioned that our final answer should not have more than one of the same variable. We should not have negative exponents or zero exponents. And then we also looked at a couple of practice problems and determined that anything raised to the zero power will automatically be eliminated, or we can change it to a 1 because the rule says that anything raised to the zero power is automatically 1. Okay. We also talked a little bit and briefly about the negative exponent rule. We said that if we do have a negative exponent or something raised to the negative power, all we have to do is move it to the other side of the fraction. Now, one of the things that I do want to mention is that sometimes the problems that we're working will already be a fraction, so it will be easy for us to move it either up or down. But some of the problems that we'll be working will not start off as a fraction and will require us to actually create a fraction so we can then move it either up or down. Okay? So with that being said, just know that we can take negative exponents, and if we move them, we'll create positive exponents. This is what we're going to do most of the time. But there will be some times where we take a positive exponent and we move it and it becomes a negative exponent. And then I'll show you some examples where we actually have to do that. But most of the time you'll be moving negatives to turn them into positives. Because remember, we're not allowed to have negative exponents in our final answer. So let's go ahead and look at some examples where we do have to apply this negative exponent rule. So the first thing I'm going to ask you to do is let's look at this problem, these problems that are right here. So notice that this problem right here already starts off as a fraction. It is already a fraction. We have numbers that are either coefficients or exponents on top. We have more than one variable here, so get used to seeing more than one variable in our problems. The first thing I'm going to ask you to do is to separate everything. So even though we look at the 2 and the x, and we usually think that they go together because that's how it has been when we're solving equations, right now I want you to understand and look at these problems and know that everything is pretty much separate. So all the bases are separate from each other. So the first thing I'm going to do is, because there's only one x, one y, and one z, I'm actually going to rewrite this to where everything is separate. We only have one coefficient, so we're going to say 2, and I'm going to separate it from the rest of the problem. I only have one x, so we're going to say x to the negative 3, separate it. We have this y squared on top, separate it. And notice that at the bottom I don't have an x, I don't have a y, because if I did I would put them in the same column as the x and the y, but I do have the z. So I'm going to put it in its own column right there. And notice that from here, I'm separating everything. This is going to come in handy, especially when we start doing the quotient rule. But we're not ready for that yet. We're just talking about the negative exponent rule. So the 2 has no other numbers to combine with. It also doesn't have a negative exponent. So there's nothing to do with the 2. But I notice that this x does have a negative exponent. So what I'm going to ask you to do, because there's not another x here to combine it with, I'm actually going to take the x to the negative 3, the whole thing, and I'm going to move it down. Because by moving it down, I'm crossing this division line, or this fraction line, whatever you want to call it. And when I cross this line, the sign on the exponent, I'm going to say that again, the sign on the exponent is the only thing that's going to change. All right, I notice that I have y to the second power. The 2 is positive, so that means that if I were to move it, it would change it to a negative, and that's not what we want. So for right now, this is going to stay on the top because this is already positive. The 2 is going to stay on top because it already is positive, the positive exponent. Now, if you look at your z to the 3 that's already at the bottom, you're going to notice that the 3 is positive. So we don't want to change a positive to a negative. So this one is also good. So everything that I put a check mark next to means that they're going to stay in that spot. The only one that's going to be moved is the x to the negative 3. We're going to drop it down to make the negative 3 a positive. So I'm going to say 2 and then y squared, because that's the only thing that gets to stay on top. I'm going to draw my division line. And because I'm moving this down, I'm going to say x to the positive 3. I have a z to the positive 3. And so this is going to be my final answer. And I'm going to tell you why this is my final answer. Number one, it says that we're only allowed to have one of each variable. There's only one x, one y, one z. So we're good there. No negative exponents. Well, we have a positive 2, a positive 3, a positive 3. So they're all positive. Check. Lastly, no zero exponents. All my exponents are actual numbers that are not zero and they're not negative. So this right here is my final answer. All right, let's look at another problem. So if you look at the one right next to it, you're going to notice that we have some x's, some y's, and z's. We have some negative exponents, but we also have this coefficient 3. So the first step is to separate everything. So I'm going to put the 3 here. Notice it's still at the bottom, but I'm going to separate it away from everything else. If I had another coefficient, I would put it on the top. Okay. All right, we have this x to the negative 1. There's no x's at the bottom. We have a y to the third power. No y's at the bottom, but we do have the z to the negative 5. And so we don't have any z's on the top, so we're good here. Notice how everything is separate in its own different column. All right, so we're going to start with this first column, and notice that the 3 has an understood 1. Okay, this 2 also had an understood 1. And because that 1 is positive, we're good. If it was a negative 1, then we would move it up. But this one's good. So I'm just going to put a little check mark there to let you know that one's going to stay at the bottom. All right, let's talk about this x. It's raised to the negative 1. We're not allowed to have a negative, so the only way to get rid of it is to move it down. If I move it to the bottom, that negative 1 will turn into a positive. All right, look at the y to the third. The third is a positive, so we're not going to move that one. And if you look at the bottom, z to the negative 5 is negative. We can't have that. So we're going to move it up. So remember, it doesn't matter if it moves to the bottom or the top. If you have to move something with a negative exponent, the sign is going to change. So this one we're moving down, this one we're moving up, but as long as we cross this division or this fraction line, it's going to cause that change. So let's go ahead and simplify this. So we said the 3 is going to stay at the bottom. We're not going to move it because it's already good. We're going to say this x to the negative 1 is going to go to the bottom as x to the positive 1. We're going to leave the y to the third on the top. And then the z, because it was negative at the bottom, if we move it to the top, it becomes a positive 5. So this is actually going to be our final answer. Why? Because I only have one x, one y, one z. We have no negative exponents, and we have no zero exponents. So in this case, we're done. This is my final answer, and so is this. So the next two problems we're going to look at, notice that they don't start off as fractions. So what happens when we do have a problem that has negative exponents, but there's no division or fraction line to move it across? So let's look at this one right here. So the first thing I notice, we have one x, one y, one z, and one coefficient. If you want to, you can go ahead and put a understood 1 on your coefficient so you know it does have an exponent and it is a positive 1. Now, even though most of these, it looks like this problem is already done, we do need to address this. This cannot be our final answer because we have a negative exponent. So because this is not a fraction, I'm going to ask you to turn it into a fraction. So you're going to draw the division line and put a 1 at the bottom. Now remember, the 1 is just a placeholder until you move something down. So I'm going to separate this. Now you can rewrite it if you want to. I like to rewrite mine because I like my stuff to be spaced out. Okay. And because this is just a 1, I'm going to put it right here, because it's also a coefficient. It's not a variable, it's a coefficient. Okay. So from here, 4 over 1 is just going to be 4. It just simplifies to be 4. We don't have to move the 4 because it has a positive 1 exponent. We don't have to move the x because we have a positive 2 exponent. And we're not moving the y because it has a positive 3. The only one that needs to be moved is a z because it has a negative 4. So I'm going to draw an arrow to remind you that we're moving it across that division line. So when we do that, we're going to have 4x squared, y to the third, and then z to the positive 4. Now, I'm not going to put the 1 there. You can if you want to, but remember, the 1 is just a placeholder until you move something to the bottom, and then it goes away. All right, the same thing happens with this one right here. So notice that I have a 5 that is raised to the positive 1. So don't think for a second that we have to move the negative 5, because we're only looking at exponents. If the exponent is negative, then that determines whether it needs to be moved or not. Coefficients can be negative all day, every day. We don't need to move those. So this one is positive, this one is negative, this one is negative, and so is this one. So what I'm going to do here is turn this into a fraction. And if you want to, you can rewrite it. So we're going to have this negative 5 here with the 1. We're going to have m to the negative 2. N to the negative 4, and P to the negative 4. And from here, you're going to notice that the only thing staying on top is going to be the negative 5, because it has a positive 1 exponent. Because it's a positive 1, it doesn't need to be moved. So don't look here, look here. All right, this is a negative, so it has to go down, down, and down. So let's go ahead and clean this up. So we have this negative 5 on the top. This m has a positive 2 once you move it down, n to the 4th power once you move it down, and then p to the 4th power. This is our final answer because we only have one m, one n, one p. No negatives, no zeros. This is our final answer. So this is using the negative exponent rule. If you have a negative exponent, the only way to undo it or to get rid of it for your final answer is to move it across the fraction or the division line. If you have a fraction, just move it. If you don't have a fraction, then create one so you can then drop it. Okay? All right, I hope these examples have helped for the negative exponent rule. We're going to start talking about the product rule, the power rule, and the quotient rule, which is our main laws of exponent rules. So I will see you in the next video.